Okay, we are going to move on to the next lesson. I'm going to blow through this one pretty quickly because I think it's pretty straightforward, and I hopefully we'll get the next video up by the end of the day today, fingers crossed, because then we'll have spring break and I won't have access to all this beautiful equipment. So get your ISOs out if you have any questions for 5.3. This will cover it, and this should be relatively quick. So multiplying rational expressions, you can read through this. And your notes is just talking about, again, the similarities, right? When you're multiplying polynomials, you're just getting everything right. Coefficients are multiplied together, variables are multiplied together. When you go look at fractions, numerators are multiplied together, denominators are multiplied together. So it's the same thing with radicals. Your coefficients are multiplied together, and your radicals are multiplied together. And the way it works, as long as we have the same index, right? So square roots can only be multiplied with square roots, cube roots with cube roots. That's going to be key. There's some example questions here. I don't want to take the time and go over them again, but it's just remembering the distributive property. So here we had 2x times 3x plus 4y in brackets. So you're going to multiply, right, both, and you're going to get the 6x squared, 8xy. Same thing if you had a binomial by a binomial. We got the old FOIL bird happening here, right? So we get these, right, firsts, outsides, insides, last, and we can break it up and we can simplify and get our final answer. And it's going to be the same rules that apply with radicals. So jumping straight in, again, of course, here we're looking, so we have a square root of 5, square root of 10, same index, we can multiply. That's going to be the square root of 50. Am I done there? No, we always have to, just like fractions with radicals, we always have to simplify. So that's going to be the square root of 25 times the square root of 2, which would equal 5 root 2. So again, nothing really crazy here. Go to B, 7 square root of 3 times 5 square root of 2. Coefficients make 35. Radicals 3 and 2 make 6. Can I simplify that anymore? No, I cannot. I will leave it as such. 2 root 3 times 3 root 3. Now there's a couple things we could do here. Myself, I still like to do the 2 times 3 is 6. 3 times 3 is 9. Even though they're the same value, it's a root 3 times root 3. We should already know the answer is 3. But I like myself to write it out. I like to see it. And then I don't make any mistakes with multiplying the 6 times the root 9 or 6 times 3. But again, as long as you're getting the correct answer, you do it your way. Square root of 5 times square root of 5, exactly what I was just talking about, right? We can say it's a root 5 times a root 5, so it's root 5 squared. We could jump straight to that equals 5. But myself personally, I do feel more comfortable if I say the square root of 25, which equals 5. That's just me. I am what I am. Same thing happens here. So this, just doing our whole distributive property equals the square root of 6. 2 times the negative square root of 10 equals, say it and write it, eh? So just going to be negative square root of 20. Can I simplify? Can I put these together? I cannot put them together, but I can in fact simplify this. This is the square root of 6. This is the square root of 4 times the square root of 5. And that becomes my final answer. So don't get lost with or forget to simplify your radicals as you're going. This one here, so we're just taking distributive, 8 root 9 minus 6 root 21. And again, I like doing this because I found that easy. I find this easier and I don't lose that 3. So this becomes 24 minus 6. Root 21. 9 square root of x times the square root of 2x to the power of 5. Again, this is just a good refresher in simplifying. So nothing too crazy here. So 9, there's 1 is the coefficient, right? So 9, 2 times 2 is 4, x times x to the power of 5, x to the power of 6. Yes, of course, I can simplify that. We can see that already. This becomes 18 square root of 2x squared. Again, I'm looking for a square root of an x squared. Again, I should recognize right away that there is simplification. And again, I wrote that equals in there. So This becomes 9 times the square root of 4. Well, square root of 4 is times 2. Square root of x power 6 is x cubed plus 18 times the x, and there's the square root of 2 in there. So my simplified 9 times 2 times x cubed is going to give me my 18x cubed, and this will give me the 18x square root of 2. Again, so there's a couple different methods we could use to get there, but they should all get us the same answer. This one here, just doing it again, our FOIL. Firsts, outsides, insides last. So 2 times 2 is 4. 2 times negative root 3, negative 2 root 3, plus 3. So this is going to be plus 2 root 3. And this is going to be minus the square root of 9, which equals 4. Well, I have negative 2 root 3, positive 2 root 3. So these, in fact, will actually cancel each other out. Minus 3, which equals 1. Now that's one thing we can, and again, if you recognize, I'm going to go back, I'm going to erase this, and I'm going to take a look at this and say, hey, one thing we should be able to do by now is recognize that 2 root 3 and 2 minus root 3, that's a conjugate pair, right? We looked at this when we were looking at the difference of squares and factoring. This is going to become more commonplace, something we got to recognize right away. If we recognize this, that it's the conjugates, then we just need the 2 times 2, and the whoops, I made that one backwards, and the root 3 times the root 3. Because the other two will cancel each other out. So that's just something to keep in mind. If I do in fact take that shortcut, I can say, well, that's just the 4 minus root 9, which equals 4 minus 3, which equals 1. So something to start catching earlier. The last one here, root x. So again, I'm just doing my FOIL. 3 square root of x squared minus 2 root 5x plus 3 root 5x minus 2 root 25, and then I can simplify 3x. I got a minus 2 root 5x, 3 root 5x. There can be like terms combined, so that's just going to be plus 1 root 5x, and 2 times square root of 25 is going to be 10, and I'm done there. So quick and painless. The only thing that you may run into is something like this. Again, it's not commonplace to run into it, but this is a really good question for remembering the rules for everything along the way. Let's see if I can make this fit on the board. So I'm going to do this here. Root x squared y. This one plus 5 root x squared y squared. This is going to be minus 3 root xy, and this one is going to be minus 15 root x y squared. Again, so I am running out of room here. The thing we got to look at here is I want to say be careful with this. Is going to be subtract 2 root y minus root x squared. The way I like to do these, and you don't have to again, but I keep that in brackets because I'm subtracting whatever this is squared. So we got to keep that in mind. And then I can rewrite this as the 2 root y minus root x times 2 root y minus root x. And then I can work on that separately. Again, there's multiple ways of doing this. I'm just doing it like this because I was running out of room. But what I can do here is, so this becomes x root y plus 5xy minus 3 root xy minus 15y x minus, and again, now I got to multiply through all of this. So this next part here, 2y times 2y is going to be 4 root y squared, 2y times minus x, plus minus x, so minus. See, and that's why I'm trying to do this too fast, and I forgot this is a negative. Okay. Minus 2 root xy, again, minus 2 root xy, and negative x, so negative plus root x squared. Now this is why I like to write this out the long way, is when I do carry this through, I find this easier. Now I have this in brackets, and I have to remember I have to subtract everything inside of these brackets. So that's going to be a sign flip on everything in there, right? So I have to subtract 4y root 2, and I can do this at the same time as simplifying. So minus 4 square root of y squared is y. Minus negative 2, so it's plus 2 root xy. Again, plus 2 root xy, subtract an x squared, so that's going to be subtract x. And I still have this big, huge, long, ugly thing, but if we take it one step at a time, this is very easy to get to a final answer to find our like terms. So I'm just going to go first with my x root y, sorry. Do I have any other similar to that? Look through, no, and I can write x square root of y. That one's done and crossed off. 5xy's. Do I have any other xy's? Look through, no. So this can just stay as 5xy. Minus 3 root xy. Do I have any other root xy's? I have one there, and I have one there. So I have minus 3 plus 2 plus 2, which is going to leave me with 1 root xy. So that's taken care of. That's taken care of. And I'm just crossing them off as I go methodically to make sure I get everything. Right? Minus 15y root x. That's the only root x I had left. I have minus 4y, done. Minus x, done, and that is that. So they all been worked through, they all been simplified. Make sure you don't go too fast. Easy to make mistakes, as I always demonstrate lovely and when I'm doing the class. And that'll be your multiplying. You're ready for the learning activity 5.3, and I will hopefully this afternoon get that divisional video up for you, and that would wrap up our, no, we still have another one after that, sorry. And that'll get our radicals almost under control. Right, so thank you very much. Happy radicaling.